Okay, so this is going to be a short lecture. In this lecture, we're going to be talking about equations of state, right? Let me just see which point we are at. We are at point number 4. So, you must remember that PV equals to MRT is nothing but an equation of state. It correlates the various states of the gases. Similarly, we had the van der Waals equation, right? Which told us how a real gas will behave. So, equation of state have a general form. All of the equations of state, they have a general form of P equals to RT by V minus B minus A by V square plus CBV plus DB square. Don't worry, you don't have to remember this. This is also given in your thermo tables. I think it is close to where this graph is given. So my point is, this is a general form of any equation of state. And when you modify the variables b, the variables a, c, and d, you get various equations proposed by various scientists. So the question will directly ask you to predict the pressure or the temperature or something using XYZ equation of state. Now, your variables A and B are defined as B naught R T C by PC and A naught R square T C square by PC. This is all of this is from your thermo tables only, so you don't have to remember anything. You only have to learn how to apply it. So your factors A and B have their values here, and to get A naught and B naught, you will look at this table. To get TC and PC, you will look at A dot 2. To get values of C and D for any of these equations, you will look at these columns. And to get the values of F, you will look it up from here. And to get the value of omega, you will get it from here. So I know that it seems a lot, but my point is everything is there in this one singular page. In fact, omega value has been calculated for these gases. So this will likely never be used. So I will break it down for you. Step 1. Which model? Which model? I mean, is it ideal gas? Is it van der Waals? Is it Soave? Which one of these is it asking you to choose? So you choose from here, this table. After you have done that, find the values of A naught and B naught from D dot 4 and T dot 1. So after you have find the values of A naught and B naught, find A and B using these formulas. Now you have A, B, and you also have C and D, because remember, C and D values are pre-calculated for all of the model that you choose. A, B, C, D will now be substituted into the general equation of state. Which was P equals to RT by V minus B, and so on and so forth. And step 4, substitute all other variables and solve for the unknown. So that is how you will use this page and these tables to find first the values of A naught and B naught according to whatever they tell you. Then you will use those values in these formulas to find A and B. Then you will substitute all of the values of A, B, C, and D into this general equation of state. Then you will solve for whatever unknown. So in your question, they will give you V, T, and then you will have to find P. Or in your question, they will give you P and V, and you will have to find T. But that will be very, very easy once you have substituted all of the other values, because then it is just solving an equation and calculators are allowed. I want to end this section on ideal gas by writing the value of R for different gases is different. No longer are we using the standard value of R, which was 8.314 joule per mole Kelvin. We cannot use this anymore. We have a specific table for different gases that tell us their values of R, the value of density of that gas, and various other properties. So whenever we use the equation PV equals to mRT, we have to use this value of R from the table. Do not use 8.314. And one other thing, the value of R also changes with pressure. However, we use value of R at a particular pressure because the change of value of R in pressure is negligible. So I think we use the value of R calculated at, I think it was 1 megapascal or something. But this is a bit of extra information. My point is, you will have to use the value of R given in the table and not this standard 8.314 that we have been using since our JEE days, So yeah, I think this concludes our section on ideal gas. After this, we will have a tutorial lecture in which we will be solving some questions related to this graph and maybe even see if we have any questions on the equation of state, although I doubt it. Right, see you in the next tutorial.